So the topic is an account of mathematical intuition as a simple computer based on observations of the growth of a imaginary biological process. Uh, and the thinking here is that we put mathematical intuition sort of front and center, and we say this is okay, a very simple mathematical computer, and uh, sorry, it's just a simple computer. Mathematical intuition is. Now, and the issue is what goes into this computer? What is the raw input? And the thinking here is that it is the uh, we're going to restrict it to being uh, uh, the visual um, textbook pages. So it's the notation that is the expression notation of the mathematical textbook. And this expression notation eventually becomes genetic sequences, and uh, the contamination issue is not introducing um, genetic material that will contaminate the result of the experiment. So we're going to run the experiment. Um, the biological media will grow, and observations will be generated. If there is contamination, then we have to throw out the observation. How do we make sure there is no contamination? One answer, the explicit scaffold. And what we do is, what we're actually now going to do is we're going to sort of slide into this kind of account of mathematics that is going to be very sort of alien and cool and damp and moist and slimy. And we're going to sort of figure out that, how set theory is really being used. It's sort of like we're going to get all conspiracy theory. And, the funny music is going to play in the background. And we're going to get all the right wingers excited about mathematics. So here goes. The thinking here is that what we really do in mathematics is we just observe, we just generate observations. And then what we do with set theory is we take the set theory axioms and then we sort of use them as a light and we kind of shine them through the observations and we try to make out axioms for the for the objects we observe. We use that theory to create these objects that obey axioms. Okay. And we use the set theory axioms to shine a light through the observations to get the observation axioms. And what we do then is we then say that those observation axioms correspond to a process that has nothing to do with set theory at all. but makes use of the language of logic, first order logic. And so all we have is a first order logic account of the observed objects. Set theory then enters as a toolkit that enables us to prove statements about the objects given the observation axioms. So the observations and the observation axioms correspond to the domain. Set theory corresponds to the programming language. Set theory is what we can do. Set theory is what we can prove. The programming language is what we can do. The programming language is what we can prove in the sense, what can the programmer prove to himself when he is asked to make a change to a program? The programmer has to make that proof. The programmer has to make that leap. If he's any good, he has to have that proof in his head as he is making those changes, as he is modifying the tests, as he is, in a sense, walking across the landscape of program source code listings, the set of all program source code listings, to a single destination, while retaining all of the specifications that are required, so there's no regressions, there's no errors that are created. So the difference between set theory, okay, and the point is that set theory is what we can prove, is our proof language. It doesn't say anything about what's true about the observations. So the observations are, to the best of our abilities, independent of set theory. This isn't 100% true, but the thinking is that this is the mythology of set theory and the mythology of mathematics. That the language we're using to describe what we see is not what we see. And we just take what we see and we say, okay, these are the truths of the objects we observe. Then we write those down, and then we come up with an account of the structure of those objects based on set theory. But we then say that that is, those axioms of those observation axioms are the abstraction barrier. So what is below the abstraction barrier is the explicit definitions. What is above is the scaffolding. Is the, I mean, in a sense, sorry, is the removal of the scaffolding.